scene from Jurassic Park 2, where we have the trailer hanging over the edge. The person tries to use the Jeep to pull them back up, but as we see, there's not enough friction, and so they both slide over the edge of the cliff. So here we want to figure out what that acceleration would be, and we can also see that the acceleration will be for the Jeep to move to the right and the trailer to move down, meaning bad news for the people involved. So the first thing that we want to do is set up our free body diagram. So for the Jeep, we have here, we can make our dot. So we're going to have gravity pointing down, and I'll go ahead and label that as mass of the Jeep times the acceleration due to gravity, G. We've got the normal force pointing up. The cable is pulling to the right, so that's a force of tension. And then we'll have a force of friction that's going to point to the left. Right, so we have two forces in the vertical direction, two forces in the horizontal direction. All right, now we want to do our free body diagram for the trailer. So in this case, we have forces that are only in the vertical direction. So we're going to have the force of gravity, m sub t times g, pointing down, and the force of tension pointing up. Now we've done these diagrams independently of each other, but the one thing that we do want to point out is which of these forces is the force that interacts between the two, because that's going to be paired by Newton's third law. So I could say that because it's the same rope, we have the force of tension that's the same for both diagrams, and so I'll indicate that with an X. So now I've erased the picture to give us some room to do our Newton's second law equations. So we'll start out with the equations for the Jeep. So for the Jeep, I can look at my free body diagram and see that I have forces in both the y direction, the vertical direction, and in the x direction. Now I've copied my axes over here because comparing to these axes will let me know which of these forces should be written down with a positive sign and which should be written down with a negative sign. So for the net force in the x direction, I could say, well, I have the force of tension points to the right, which is the same as the direction of my positive x-axis, so Ft is written down with a positive sign, and the force of friction points to the left, so I can write that down with a negative sign. Those are all the forces in the x direction, so now I need to set that equal to ma, right? So which mass? Well, it's the mass of the object that I'm looking at, so that's m sub j, the mass of the Jeep, and it's the acceleration of the Jeep. Now I know that the Jeep could possibly have some acceleration in the horizontal direction, so I have to put that as an unknown. Okay, so then if I look at in the y direction, I can say the normal force points up and the force of gravity points down. So the normal force points up, I write that down with a positive sign, and then the force of gravity points down, I write that with a negative sign. Now there's no acceleration of the Jeep in the vertical direction, right? It's on level ground, it's not going to be leaping up off the ground or crashing down through the ground. So the acceleration in that direction is 0, so I can write that like this. So that gives me two equations so far. Okay, so now I can get one more equation by looking at the free body diagram for the trailer. Okay, now let us look at the free body diagram for the trailer. So here we can see that there's forces only in the vertical direction, so I know I'm only going to get one equation for the trailer. So F net in the y direction, again I have my axes copied here, so I know that upward is positive, so the force of tension is written down with a positive sign, and the force of gravity is written down with a negative sign. And that's going to be equal to ma, and that's the mass of this object, so the mass of the trailer, mt, times the acceleration of the trailer. All right, so now I have a third equation. So these three equations in boxes represent all of the information that I can get out of the free body diagrams. So I have all my forces. Each one only involves the forces on that object. And for the case of the Jeep, it's broken down into one equation for everything that's happening in the X direction, one equation that's happening in the Y direction. For the trailer, everything's in the Y direction. Okay, so now I will copy these equations and then we'll see what we can do with them. Okay, so we've got our equations copied down over here. So that represents everything that we were able to get out of the free body diagrams for the two objects. Now we're trying to solve for the acceleration, and to do that, we have to make a couple more observations about the physics before we can just start doing algebra. So the first thing to do is to compare these two accelerations, the acceleration of the Jeep and the acceleration of the trailer. So they're tied together, so when the Jeep moves a little bit, the trailer is going to move by the same amount, but the Jeep's moving in the positive X direction while the trailer moves in the negative Y direction. So that means that whatever acceleration the Jeep has is going to be equal to negative time of the acceleration of the trailer, right? They'll have the same magnitude but opposite sign, and that's because of our choice of coordinate system. So we can get rid of these subscripts by just defining this as the overall, the only acceleration in the problem is, and we'll make it the positive one for the Jeep. So that means that if I want to simplify this equation, I can just get rid of the subscript j, because the acceleration that we've defined is equal to the acceleration of the Jeep. And then when I do that for the trailer, I can get rid of the subscript, but I have to put a negative sign there. Okay, so that's the first observation that we have to make about the physics. So that simplifies our equation, our algebra a little bit, because we know that this acceleration is the same as that one. Okay, now the other thing that we have to do is we note that there's a force of friction in this equation. And neither of these equations are something that we can immediately just solve for the acceleration, right? Because the tension is an unknown force. So I need to remember the definition of friction. So the friction, well, it's acting on the Jeep, so it's going to depend on the normal force of the Jeep. So the definition of friction is that the force of friction is equal to the coefficient of friction mu, which was given for us in the problem statement. It was 0.4, and then times the normal force. All right, so with that information and with the rest of these, now I can solve for the force of friction and then use that in my other equation. So this equation for the vertical direction of the forces on the Jeep, it's equal to 0 because there's no acceleration in that direction. So the primary time where we would care about using this equation is when we have to know the normal force so that we can solve for the force of friction, which is the case in this problem. So simple rearrangement shows me that the normal force is equal to the mass of the Jeep times the acceleration due to gravity, and I can plug in what I know there. So I know that the mass of the Jeep is given as 500 kilograms, multiply that by g, 9.8 meters per second squared. That gives me a normal force of 4,900 newtons. Then when I calculate the force of friction, that's mu times the normal force. So we're given that mu is 0.4 times the normal force of 4,900 newtons, which gives us a force of friction of 1,960 newtons. Okay, so that's all the information that we can get out of this vertical equation. We know now the force of friction. So now that I look at my two remaining equations, I don't know the acceleration, I don't know the tension in both of these equations, but I know everything else. So now I'll be able to use my two equations with two unknowns and solve for the acceleration. So now I've reduced everything down to two equations where I don't know the acceleration and I don't know the force of tension. And you'll notice that I put the minus sign from the negative acceleration out in front here. So there's lots of ways to do algebra. So at this point, it's all algebra. It's no longer any, there's no new physics that needs to go into it. But the strategy that I always suggest is, if I look at these two equations, there's two things that I don't know, but I only care about one of them, right? I only care about the acceleration. I don't care about the force of tension. So it's kind of counterintuitive, but I will solve for the force of tension algebraically in both equations. So first, I'll take this equation and add the force of friction to both sides. So I've got force of tension is equal to mass of the Jeep times acceleration plus the force of friction. And then this equation here is going to become force of tension is equal to negative mass of the trailer times the acceleration plus mass of the trailer times g. Now, the right-hand sides of both of these equations are both equal to the force of tension, so that means that this expression is equal to this expression. So I can write that down as a single equation then. That becomes the mass of the Jeep times acceleration plus the force of friction is equal to negative mass of the trailer times acceleration plus mass of the trailer times g. Okay, now I need to get all the terms that involve acceleration on one side and all the terms that don't involve acceleration on the other side. So I can add m sub t times a to both sides, so I'll do that, plus m sub t a plus m sub t a. And I'll also at the same time subtract the force of friction from both sides. You can do that in two steps if you're more comfortable that way. So that gives me the mass of the Jeep times the acceleration plus the mass of the trailer times the acceleration is equal to the mass of the trailer times g minus the force of friction. Okay, and then finally I can factor out the acceleration a, so that's a times the mass of the Jeep plus the mass of the trailer is equal to the mass of the trailer times g minus the force of friction. And then divide both sides by this total mass. So m sub j plus m sub t divided on both sides. Okay, so taking this algebraic expression which we have here, up over to this side, so I've solved for the acceleration, which is equal to the mass of the trailer times g minus the force of friction, and that's all divided by the mass of the trailer plus the mass of the Jeep. So I plug in values here. Mass of the trailer is 1,000 kilograms, g is 9.8 meters per second squared. The force of friction we calculated earlier to be 1,960 newtons, and then divided by the total mass, 1,000 kilograms plus 500 kilograms. Plugging in all those values, I get an acceleration of 5.2 meters per second squared. Now that's positive, which means that the acceleration's in the positive x direction for the Jeep, which makes sense. They're going to go over the edge of the cliff. And it's also less than the acceleration due to gravity, which makes sense because we have friction involved, so there's other forces other than gravity that are tending to work against gravity, and therefore the acceleration should be less than g.